Mr. Harmless here, and I'm dealing with special right triangles. And so let's put that up here at the top. Special right triangles. Okay. And they're called special right triangles because they're two unique cases, and there's a lot of reason for this, but there's two unique cases that we learn in high school geometry that are shortcuts to solving for different sides of right triangles. And with the two special cases that we deal with are when a triangle is a 30, 60, 90, right? Or a 45, 45, 90. So these are the two unique cases that we're going to learn basically shortcuts for. And the shortcuts have to do with the relationships of the sides. Now, I have two other videos where I already talk about this, but this video is for those people who love, right? So put a little love formulas. Okay. So if you are a person who loves little formulas and loves memorizing little formulas, this little video is just for you. Okay. So we're going to put some formulas to this. So the first thing you have to be able to do is identify what triangle you're dealing with. Notice this one is a 30, 60, 90, not just because I labeled it up here, but because you can see 30 degree, 60 degree, 90 degrees, right? In a 30, 60, 90 triangle, the hypotenuse is always still the same, right? Hypotenuse is always opposite the right angle. So this is my hypotenuse. Okay. Now, notice that the legs are not the same length, right? Opposite the 60-degree angle would be my longer leg. So I'm going to call this is a really technical name for the long leg in geometry. It's called the long leg. And the technical term for this other leg is called the short leg. Okay. In a 45, 45, 90 triangle, the legs are the same length because it's an isosceles triangle, right? It's an isosceles right triangle. The legs are, these angles, because they're both 45, means that both these legs are the same exact length. So we can label the legs being the same length by putting little lines through them. And so we don't have a special different name for the legs, right? Because they're the same. So we can just call each a leg. The hypotenuse, once again, is still the side that is opposite the right angle. This is my hypotenuse, okay? Now, it doesn't matter which way the triangle is facing. The hypotenuse is always opposite the right angle. That never changes. So whether it's facing this way or flipped around the other way or upside down, it doesn't matter. Hypotenuse is always opposite the right angle. Okay, now, once again, this is for those that love formulas, right? So if you're like, I love a little formula, I don't want to try to figure it out, just tell me what I'm supposed to do. This is for you. We learned that with a 30, 60, 90 right triangle, right? 30, 60, 90 triangle, that the relationship between the short leg and the hypotenuse has to do with the number 2. It's double. Hypotenuse is double. So if you like formulas, you could write this. You could say, well, the hypotenuse is equal to 2 times, and I'll abbreviate, short leg. If you're a formula person, if you're trying to find the hypotenuse, you can just say 2 times the short leg. If you're trying to find the short leg, then the short leg is equal to the hypotenuse divided by 2. Now, even with my most prolific formula people that just love formulas, sometimes even after I write this, they go, oh, wait, well, that makes sense, because if it's going, right, it's double it, so I'm going to multiply by 2. To go back to, I'm going to divide by 2, okay? But if you like formulas, these are two formulas for the 30, 60, 90 triangle. The other two has to do with the long leg. Notice we haven't mentioned the long leg yet. So the relationship between the short leg and the long leg isn't double the size like the hypotenuse. The long leg is square root of 3 times bigger, okay? Which means if you want to find the long leg, you can take this short leg, abbreviate here, times the square root of 3, because it's square root of 3 times bigger than the short leg. Which also means that if you want to then find the short leg, you have another formula here. We had one over here if you know the hypotenuse, but if you don't know the hypotenuse, you can find the short leg by doing the long leg divided by the square root of 3. Okay, so this is the things that you would need to know for a 30, 60, 90 triangle. Now, the 45, 45, 90 triangle is a little bit different. Notice it doesn't look the same, so it wouldn't be the same relationships here, okay? This one, the only number that you need to remember is the number of the square root of 2. The hypotenuse is the square root of 2 times larger than the leg. And so if I said, well, what is the hypotenuse? And I was trying to find the hypotenuse, I could take the hypotenuse would be equal to the leg times the square root of 2, because it's square root of 2 times larger than the leg. Now, if you have the hypotenuse, you're trying to find the leg. Well, since it's square root of 2 times bigger, you just divide. So I could write this little formula. Leg equals the hypotenuse divided by the square root of 2. So these are the two things that you'd need to know for a 45, 45, 90. So for a 30, 60, 90, this is what you need to know. For a 45, 45, 90, this is what you need to know right here. Okay. So if you love formulas and you like remembering formulas and using formulas, this can be helpful to you. And I made this video just for you. Hope that it's helpful. Thanks for watching.